Exercise 164, page 418, question 8 is an interesting one. I've got three functions multiplied together this time, e to the t times log t times cos t. So we can call one u, we let that equal u, e to the t equal u, say, and then we let log t cos t equal v. So now what I have to do is, effectively what I'm going to have to end up doing is using the product rule twice. But if we now apply the rule and see what happens, so if I let u equal e to the t, then du by dt equals e to the t. So that's fine. Now what about v? v equals log t times cos t. So effectively what I've got to do now is use the product rule on this. I've got this one say equal a, and this bit equal b. So then the product rule tells me I've got to differentiate. I've got to take a equals log t and differentiate that. So the a by t equals 1 over t. And then I've got to take the b part, which is cos t, and differentiate b with respect to t. And get cos minus sine t. And then the product rule for this part of it means that the v by dt equals a, which is log t, a times the differential of b with respect to t, plus b times the differential of a with respect to t. Same idea of the rule. First bit multiplied by the differential of the second, plus the second bit multiplied by the differential of the first. So what does that equal? That equals a, which is log t, times the differential of b, which is minus sine t, plus b, which is cos t, times the differential of a, which is 1 over t. So I can mess up a bit and writing the second term first, I get 1 over t times cos t minus log t times sine t. And that turns out to be dv by dt. So now I've got v, which is log t cos t. I've got the v by dt, which is 1 over t plus t minus log sine t. And I've also got u over here, which is e to the t, and the u by dt, which also is e to the t. So, let's plug in that all together, back into the product rule again. I have the y by dx equals u dv by dt. I don't like dx. U dv by dt plus v times du by dy by dx dt here. So that equals u, looking back up, u equals e to the t, times dv by dt, which is this whole term here, this whole term, dv by dt, is that. So dv times dv by dt, so I'll put all this in brackets, 1 over t cos t minus log t times sine t. And then that's all got to be plus, so let's shift it over this way a little bit. So it's plus v, which is log t cos t, log t cos t times du by dt. U by dt is just e to the t. So that's the answer. We can try tidying it up a bit. How will we tidy that up? No obvious ways to tidy it. So that will probably do as the answer. Actually, looking again in the textbook, looks as though they've multiplied out these brackets to get that answer and then taking the e to the t outside the bracket. So let's see what they've done. E to the t, O times 1 over t, cos t, minus e to the t log t times sin t, plus e to the t log t cos t. So you can take e to the t outside that bracket altogether. E to the t brackets 1 over t cos t minus log t sin t plus log t cos t. And if we look at that, we could, inside this square bracket, take log t outside another bracket. So we get e to the t 1 over t cos t 1 over t cos t, and then minus, taking log t outside a bracket, we can get the sin t. Got to be a bit careful because now we have to say minus cos t. So that when I multiply back out, I get minus log t times minus cos t. It's plus log t. The other way to do it would be to, which is probably what they've done in the text, plus log t, and then swap these two functions inside cos t minus sin t. If you multiply that out, you'll check that too, gives the right answer. So quite an awkward rearrangement.